Okay. Okay, in class we talked about looking at a circuit with transistors, CMOS transistors, and determining what type of circuit that would be. Of course, this says it's a CMOS NOR gate, but suppose you didn't know that. How would you figure it out? All right, so let me get the pin. Oops. Let me show the pin options. Okay, so get out a pin. And remember, what we can do here is we can look at all the combinations. For example, what if we put both of these inputs low? Okay, so two lows here. Since there's a bubble, that turns on these transistors, so they act like switches, and that's a short across there. Okay, so all the current can flow there. Another couple of lows here. Sorry, that's a low to that bubble. That's a short. And so we immediately have a connection from Z up to VDD. So with just a few things, I can figure out that's a high. All right. Now it turns out for a circuit to be consistent, Z shouldn't be also connected to ground. If we did that, there'd be a short circuit, and that would be bad news. Okay, so if this is a low, then on the bottom half of the circuit, you trace this line from here, and you see this is also a low. Because they don't have bubbles, these transistors are still open. Okay, so you see we've blocked the path. There's no path for current to flow from Z to ground. All right, so that tells us that if you put a couple of lows here, low, low, on the output, you get a high. Okay, so that's one combination. All right, so let's clear the ink on the screen. And let's look at the next combination. Let's say we had a low and then a high. All right, so you see, because there's a low here, this acts like a short. Because there's a high on the bubble, this acts like an open. And immediately you see there's no path from Z back up to VDD. All right, let's check out the rest of it though. This is a low following the lines. This would be a high following the lines. Okay. So this transistor is open, but this one's closed. All right, so since it's closed, there's a path from Z down to ground, so therefore Z must be tied to low. So with this combination, low-high, this should be a low. And in fact, you can kind of look at this architecture on the bottom. These are in parallel, so any combination where one of these things is a high, okay, any combination where one input's high is going to tie that back to ground. So we end up with this pattern, high, 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 low, low, low. For this particular truth table, this gives us the NOR gate. Okay, so let's do another gate. Okay, this one's a little bit harder because what you have to do is you have to break this out into two pieces. Okay, so I guess let me back up a little bit. You have to recognize a CMOS inverter circuit. Okay, so let's talk about that. So pull up the pen. This is an inverter circuit. Let's say we put a low in here. A low here shorts this because I hit the bubble, right? And so I get a high on the output. All right, to be consistent, this would not be connected because low here opens that transistor. So a low on the input gives you a high on the output. Okay, so let's erase the pin and do a high on the input. a high on the input here opens this circuit, okay, but it shorts this one because the switch is closed. All right, so V out would then be a low. Okay, so you can see how that acts like an inverter. Now let's go to the AND gate to talk about the analysis. All right, so let's say you didn't know this is an AND gate. How would you tell? Well, what I recognize is that this part is an inverter, okay? And then the front part here is a NAND. It's really messy writing. So if I take a NAND and I invert it, I get an AND. Okay. So let's see why this is a NAND gate. Let's move forward and look at another circuit. Okay. All right, so let's pretend we don't know this is a NAND gate and see why it would be. Okay, put the pin on here. So notice if we have, let's start with the first combination, low, low, low. Okay, if all these are low, then I break off this path. Right? Not only do I break it off 3 times in a row. So there is no path to Z. On the upper half, though, notice if I have lows, that's a short, that's a short, and that's a short. So clearly I have a connection to VDD. So if all of those are low, I get back out a high. Right? So then you can ask yourself the question, well, geez, what if just one of these 3 inputs was a low? Okay, and it doesn't matter which one, right? So let's clear the ink. It doesn't matter which one. Let's choose the middle one. If one of these is a low and the other 2 are high, it just takes one in the lower path to turn off that transistor. These other 2 are on, so the path's almost made, but it just takes one. The path is not made down to low, right? Then in the upper half, the middle one, following this, hits the bubble, closes this, so there is a path from Z to VDD because the B input's low, making this a high. All right, so you see you've taken care of a lot of combinations. Okay. If any one of these inputs is low, so you see that, this whole thing, something's low in every one of those entries in the truth table, that forces the output to be high. Okay. One last case for this circuit. If they're all high, then I think it's pretty clear what happens. They're all high. That means all 3 of the transistors, God, it's a bad high. All 3 close, and I have a path to ground. All right, so that forces that to be a low. And for consistency, we can look at the upper half. If all these are high, then every one of these are open, and it blocks all paths, the parallel paths, blocks all parallel paths to VDD. Okay, so that gives you an idea of what I want you to be able to do in terms of identifying gate types by looking at transistor circuits.